The Control Configuration tab contains 7 drop-down fields: VAV configuration, ECM motor, CO2 control, auxiliary heat, space sensor, discharge air sensor, and exhaust fan. The VAV configuration drop-down field can affect the fields in the Flow Configuration tab. For example, if I were to select a dual duct box as the VAV configuration, the heating section in the Flow Configuration tab is enabled. Otherwise, it stays disabled. We have 26 different types of VAV configurations that you can go from the cooling only to no fan four stage to parallel fan four stage. We even have hot water valves that are modulating and floating. We even have SCR heat. Again, we have parallel fans, series fans, with both stages of heat as well as hot water. We even have dual duct applications and a ventilation application. Next is the ECM motor. Does the fan, if it's appropriate, does it have a variable type of control? If the answer is NA, then the answer is no. Otherwise, we will be selecting ECM. The CO2 control indicates how the VAV will receive a CO2 sensor. Is it going to receive the CO2 from a T-stat? This is obtained from a digital thermostat. CO2 from UI6. The CO2 value is received from a sensor that is connected to the universal input 6 terminals. Or is it going to receive its value from the Fox network from a source outside of the Edge VAV system? Then we have auxiliary heat. This setting indicates whether the VAV uses auxiliary heating and what type of control. Auxiliary heat is a method of supplementing the normal reheat control in a space in colder climates. Control is based on the primary heating loop, which also controls the box reheat. There are 3 different types of auxiliary heating controls. With digital and analog, we have fin tube, radiant, unit heater, and duct booster. If no aux heat is selected, auxiliary heating signals are set to 0. If it's digital, then it's on-off control based upon an enable set point, which the default is 60%, and the disable set point, which the default is 40%. If it's analog or floating, each control signal equals the primary heating loop. Then we have the space sensor. This determines how the controller gets the space sensor from the VAV, or for the VAV. We have the 10K thermistor. We have the digital temp, which contains temperature, relative humidity, CO2, or VOC. The touch temp currently is not available, as this will be for our companion sensor, which will not be released until later on this year. We also have the Viconics 8350 backnet sensor. We can receive the value from a Niagara network, or we have ACI sensors that we can look from as well. Then this is going to select whether or not we have a discharge air sensor. And the exhaust fan is going to be selected based upon the need to relieve the amount of air in the space for cooling purposes. This is either done by no configuration at all, turning on and off based upon the occupancy of the supply air unit time schedule, the cooling set point, which the fan starts when the space temperature rises above the VAV controlling set point plus a differential. We can also have manual control from the Fox network via the supervisor, or with the set point delta. This starts the exhaust fan when the space temperature rises above an exhaust fan cooling set point, which the default is 90 degrees.